Hello, today's lesson, let me see if I can make this a little better. There we go. Today's lesson is 7-6. We're doing operations with our radical expressions now. So we're going to start with, this is page 49 if you're following in your book. Make sure you're taking all of your notes. This is adding and subtracting radical expressions, okay? The radicands, which is the number inside the radical, those must be the same in order to add them. They must be like. So just like when you're doing fractions, how the denominator has to be the same, to add numbers with radicals, the radicals must be the same. Okay? So example 1, pretty easy. I'm just showing you in theory what's going on. I've got 3 to the square root of 7 plus 7 to the square root of 7. The 7 doesn't change, just like with denominators. And I'm going to go 3 plus 7 is 10. You don't have to put that in parentheses, so you're just going to write it as 10 to the square root, oh, that should be a 7. 10 to the square root of 7. Almost wrote 10 again. There you go. So example 2. Now we have radicands that are not the same. So I have a 40 and I have a 135. This is a cubed root this time. Well, let's see if I can't make them the same. I'm going to start by factoring. I'm going to factor over here to stay away from my work area. So I have 40. Well, 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. This is a cubed root, so I found my group of 3. So I'm going to take a 2 out and leave a 5 in the cubed root. So I'm going to rewrite this over here as 6, and then in parentheses I'm going to put this. 2 to the cubed root of 5. I'm going to put my minus, and then we're going to factor 135. 135. That is it divisible by 3? It is. 135 divisible by 3 is 45. 45 divided by 3 is 15. 15 divided by 3 is 5. Oh, look what just happened. I have a group of 3 3's, so I'm going to bring out a 3. And I have a 5 left over. That goes in my cubed root. So now we have matching radicands. So over here I have my 2 up front, and then in parentheses I'm going to put this. 3 to the cubed root of 5. So before I can do anything, I need to multiply these, so I'm distributing, but you can only multiply like numbers but like numbers. You cannot multiply this with a cubed root because it does not have a square cubed root with it. So I'm doing 6 times 2 is 12, and then to the cubed root of 5 minus 2 times 3 is 6 to the cubed root of 5. Now I can do, you're only subtracting like things. Those are the same, so we can subtract, but 12 minus 6 is 6. So my answer is 6 to the cubed root of 5. Okay? It's pretty simple. I think you have a check for this one. Yes, you do. Press pause. Make sure you're doing your check. Okay? I'm going to first notice that my radicands are not the same. So I'm going to factor out 50 and 32. So 50 divided by 2 is 25. 25, I can divide by 5 and I get 5. So this is a square root. I have a group of 5 that I'm going to pull out, and I'm going to leave a square root of 2. I'm going to rewrite it over here, negative 11, and put this in parentheses. 5 to the square root of 2. Plus, it's going to be 2 times whatever I get when I factor 32. So I'm going to come factor 32. It's going to be 2 and 16. 16 is divisible by 2, and I get 8. 8 is divisible by 2, and I get 4. 4 is divisible by 2, and I get 2. Looking for groups of 2. There's a group of 2 2s. There's a group of 2 2s. So 2 times 2 is 4. And I have a 2 left over that goes back in my radical. So over here it's 4 square root of 2. Now I have matching radicands, but I got to multiply first. Negative 11 times 5 is going to be negative 55. Square root of 2. 2 times 4 is going to be 8. Square root of 2. So now you got to do negative 55 plus 8. So negative 55 plus 8. That's negative 47. And then we bring my square root of 2. So my answer is B. Okay. Word problem. Kate is decorating a rectangular pavilion for a party and wants to string lights along the edge of the roof. 2 of the sides have a combined length of 26 to the square root of 5 feet, and the other 2 sides have a combined length of 12 to the square root of 45 feet. How many feet of lights will Kate need to decorate the entire pavilion? So the expression this plus this represents the total perimeter. So they gave that to me. Okay. So they kind of did the work for us. But what we have to do here, this we cannot factor anymore. 5 is as low as it's going to go. So we have to factor out the 45. They already told us we're going to ignore this part. We're going to factor out 45. Okay. 45 divisible by 3 is 15. Divisible by 5. Wait. Yeah, 5 is 3. I did that weird. I should have done 3 then 5. It doesn't matter. I have a group of 3s. That's how they got the 3 squared. Ignore that. So I'm bringing out 3 to the square root of 5. Okay? I'm bringing out 3 to the square root of 5. So I'm just going to rewrite it down here because it's going to make most sense to me. 26 to the square root of 5 plus 12 times 3 to the square root of 5. Because I had the 12 and then I factored 45. So I'm going to bring this down because I'm not going to use it. And then 12 times 3 is 36 to the square root of 5. Now we're to where they were. Okay? Now we have to do 26 plus 36, which is 62, to the square root of 5. And that's how many feet of lights we need to decorate the pavilion. It's a weird way to set it up, but hey, this is algebra. And now if I recall, yep, you have a check. Pause. Try it on your own. A business is adding wheelchair ramps to their building. The 2 ramps will require this many feet and this many feet of concrete. How much concrete will be needed to build the 2 ramps? This and this, we're just adding. So let's write the equation. I'll write it over here. I've got 10, it's an expression, not an equation, square root of 28 plus 4 square root of 112. Not the same, so I need to factor both of them. So 28 divided by 2 is 14. Divided by 2 is 7. Pair of 2's, I have 2 to the square root of 7. That's over here. So 10 times 2 to the square root of 7. Now we're going to do 112. Divided by 2 is... Woo! I should know that. I'm just not awake yet. 56. 56 divided by 2 is 28. 28 divided by 2 is 14. Now we're matching up here. Divided by 2 is 7. Looking for groups of 2. There's a group of 2. There's a group of 2. 2 times 2 is 4. Left over with a 7. So I'm doing plus 4 from there times 4 to the square root of 7. Okay, first distribute in. 10 times 2 is 20. Square root of 7. Plus 4 times 4 is 16. Square root of 7. And then 20 plus 16 is 36. Square root of 7. Oh, look, my answer is C. We're almost done. One more example. We're going to learn multiplying radical expressions. So it's similar to multiplying rational numbers. To multiply radical expressions, first you multiply the coefficients, and then you multiply the radicands. So this 5 gets multiplied by this 2, but this 3 gets multiplied by this 7. Just like how when you're doing rational numbers, fractions, that you multiply the top by the top and the bottom by the bottom. Okay? Let's go try it out. Pages are sticking together. Easy peasy. I've got 5 times 4. So I'm going to do this. 5 times 4 is 20. And then 3 times 6 is the square root of 18. But this is not your answer because you have to think, can I reduce this number? So I'm going to go 18 divided by 2 is 9. Divided by 3 is 3. Pair of 3's. Pull it out. Left over 2. But now I'm going to multiply 20 times 3 to the square root of 2. 20 times 3 is 60. Square root of 2. There's your answer. Okay. You have a check to try on your own. Pause. Try it. 3 times negative 9 is going to be negative 27. 10 times 6 is going to be the square root of 60. Factor 60. 60 divided by 2 is 30. 30 divided by 2 is 15. 15 divided by 3 is 5. Square roots. Group of 2. 2. 3 times 5 is 15. Negative 27 times 2 to the square root of 15. Negative 27 times 2 is negative 54. Square root of 15. And there you have it. I'm not going to assign the McGraw for this one until next week. Right now, you need to make sure that you finish. Did you finish 7-5 McGraw? Make sure you go do it. Okay, it's due tomorrow, Friday. Have a great day, guys.